I'll take a different example here. This is a map of southern Oregon. This is Upper Klamath Lake, a very big lake in the high desert of southern Oregon. This is a river called the Williamson River that flows into that lake. I happen to own a ranch that's called Hexagenia Ranch, and that's where I'm speaking to you now from. It's the picture in my Zoom background here. It's pretty far out in the wilderness here, but one of the things one wonders as a ranch owner is what is the distribution over how high does this river get in various years, and what is my risk of various levels of the river flooding various parts of my property. And you can see in the picture in the background here, that river, if it comes over the bank, can come right up onto the property. So I just went and got the data just for interest from the United States Geological Survey, and here's 95 years of data. They've kept track every year of what was the actual maximum gauge height for that year, for different years of the Williamson River, and that goes all the way from 2 to 10 feet. And the question is, what if you fit that data to a metalog distribution? Well, there's 2, 4, 6, 8, 10. I originally had no idea what that shape might mean. You can see that it does a pretty good job of representing the histogram. And I one time presented it, and there was a hydrologist in the audience. It's the first time I'd ever presented this to a hydrologist. He said, "Oh, I can tell you exactly what that means." I said, "What?" He said, "Yeah." He said, "That's telling you about the shape of the river." I said, "What do you mean by that?" And he says, "Well," he says, "the river has a V in the center, and it flows up, pretty quickly, fills up that V, and then it has a wide flat area where the banks go up in a wide flat area, and there's a flat area there." And I thought, wow, again, there's an insight for an expert in a field that can interpret something from the data that you might not have seen by just looking at the data.